Hello guys, welcome to the channel. In this particular video, I will explain the problem smallest positive missing number. So the problem is asked by companies like Amazon, Samsung and Ecolite. Let me start with the problem statement. The problem statement is quite easy and straightforward guys. It says that you are given an array ARR of n integers including 0, which means that the array can have negative numbers, positive numbers and zero number, right? Now the task is to find the smallest positive number missing from the array. So one example is given here. Let me explain the problem with the example. We are given an array which contains the element 1, 2, 3, 4, 5. Now for this array, our task is to find the first missing positive number, right? So what we can do is we can start from 1 and then we can like keep checking and keep increasing the number till we have found one number. Let me explain how. So 1 is present in the array. Yes, 1 is present. So we will move to 2, right? 2 is present in the array. Yes. So let's try out 3. 3 is present in the array. Okay. After this, what about 4? 4 is present in the array. Yes. Similarly, 5 is also present in the array, right? And now I will move to 6. So 6 is not present in the array. So this way 6 is going to be the first element which is not present in the array, right? First missing positive number is 6 here. Now let me take another example. So let's say we are given an array which contains the element -1, 0, 1, 2, 3, 5, right? Okay, so now again I am going to do the same process. I'll start from 1. 1 is present in the array? Yes. What about 2? 2 is present in the array? Yes. What about 3? 3 is also present in the array. Then I'll try out 4. Then 4 is not present in the array, right? So for this example, 4 is going to be the output. Now I hope you have understood the problem statement. So let's talk about the solution now. Okay, so I have written one example here and you can see here that I have an array, right? And now before we talk about any particular approach, I want you to make a very important observation here, right? Let me explain what is observation. So one thing that we can notice is we are given an array of size n, right? So this array can contain, in the worst case, this array can contain from element from 1 to n, right? You can see that for this example, we are given an array of size 5. So this array contains element from 1 to 5, right? And when this array contains the element from 1 to 5, then there is no any positive number. Then the missing positive number is n plus 1, right? Which is 6. Okay, and the another case is, let's say that like there are 1 to n empty places, right? So there is a possibility that any of the number from 1 to n can be missing, right? So the answer can be I mean from 1 to n, either from 1 to n, or if 1 to n or element are present, then the smallest positive number will be n plus 1, right? Because this is the smallest just after the element n. So this means that the answer is going to lie from 1 to n plus 1, isn't it? So this is very important observation, that answer is going to lie in the interval from 1 to n plus 1. Okay, so this is the first observation that we have made. Now as we have made one observation, so we can talk about the solution. And the first approach that I will write is quite similar to this one, right? We can start from 1 and then we are going to try out every element, and if the element is present, then I will increment the element. Let's see how we can do this. I will have n which is initially equal to n 1, right? Because 1 is the smallest positive number, and I will check if 1 is present. Yes. So while true, I will check whether the element is present in the array, right? And if it is not present, then I will increment the element and I will try out the next number, right? Fine. So when I say while true, then this loop is going to run and run and run till we reach a breakpoint. What is the breakpoint here? If I have found one element which is not present in the array, in that case, I'll say that I have to stop, right? So I'll say if n is not present, if n is not present, in that case I'll simply return n, right? Return n. Why? Because you can see that if n is not present, then n is going to be the first element which is not present in the array, first missing positive number. So that's why I'm simply returning the value of n. This is the approach that we can follow in order to find the solution, right? Now the question is how to check this particular thing optimally, right? how to check this particular thing. So when I say checking whether n is present in the array, so the first approach that you will think of is we can simply check in the array, right, which is o of n, this is like doing a linear search over the array, and then we can simply tell whether n is present. So the complexity of this approach is uh, time complexity is how many times this loop is going to run. We have already discussed one thing, that the answer is going to lie in the range from 1 to n plus 1, right? So o of n, this means that I am going to check out n element in worst case, so this means that this is o of n, right? And inside this again o of n, so the time complexity will be o of n square, right, for this approach. And after this the space complexity will be o of 1, isn't it? This is the first approach. But what we can do is we can do some optimizations in this approach, and when we do this, then I can convert this particular like problem into finding the element in an array, right? So in order to solve this, we can use something which is set, right? I can use a set. Let me choose red color here, so I can use a set. And what's special about set is set allows us to check the presence of an element in just o of 1. So once I have stored all the element in a set, then I can check if n is present in just o of 1, right? And this is going to optimize the problem a lot. So the new time complexity will be o of n, right? This is the optimized time complexity, and the space complexity is o of n here again, right? Why o of n? Because I'm using a set data structure here where I'm storing all the elements. I hope you are able to understand this particular approach, right? Now this approach is o of n approach, right? And the problem with this approach still is we are using some extra space, but we can optimize this as well. We can optimize the space complexity as well, and this is going to give us the space complexity as o of 1, right? So let's see how we can do this. And by this, let's talk about the second approach. For the second approach, this is going to be really interesting. Let's see how. What we can do is, we know the answer is going to lie from 1 to n plus 1, right? So let me write the element from, let's say the size is here 5, right? So I'll write the element from 1 to 6. 1 2 3 4 5 6, right? Okay, so once I have matched every element in the like with the correct index, when I have matched every element with the index, then I can get this particular order, right? And how I can do this? I can simply get the order is 1 should be present at the first place, right? Let me write here. One should be present for this array. One should be present at first place. Two should be present at second place. Three should be placed at third place. Four should be present at index which is 3, right? But 4 is actually present at fourth place, and 5 is present at fifth place, right? Now I can compare these two values. So you can see that every element is present at that their place, right? So for this particular example, the answer is going to be 6. And how I'm checking this? I'm simply checking one thing. For every element I equals to 0, I is more than n, and I plus plus, right? I will check whether the element at like index I is I plus 1. You can see that element at index 0 should be 1, element at index 1 should be 2, element at index 2 should be 3, right? Because this is 0 based indexing. So I'll say that if array of I is not equal to I plus 1, so for that particular example, I can write that return I plus 1. Return I plus 1, right? And this is going to give me the first missing positive number. So instead of taking this example, because for this example, you can see that nowhere in the loop I will get a particular condition where the element is not present, because every element is present at their place, right? So at last I can return n plus 1. This is about this particular example, but let's say I have another example which is -1 0 1 2 3, right? So for this example, okay, let me take 1 2 3 5, right? For this example, I'll start first of all I'll write every element at their matching indices, right? So 1 should be present at first index, 2 should be present at second index, and 3 should be present at third index. After this 5 should be present at fifth place. Then what about this 0 and -1? 0 and -1 can be present anywhere. I'm not concerned about them. 0 -1. Why I'm not concerned about these two elements? Because these two elements are either 0 or negative element, right? And our task is to find the first missing positive element pay attention here, I am talking about positive element only, right? That's why I am writing every positive element at their correct place. So now if I compare this particular array with this particular form, then you will notice that 1 is matching, 2 is matching, 3 is matching, but 0 is not matching, right? So this is the place for element 4, right? You can see that array of I for this, which is 0, is not equal to 4. So in this case I have to return 4 because 4 is the first missing element. So this is something that you need to do. But before this the task is to write every element in their correct order, right? So first step is to write okay, I'll say match index with a respective element, right? Respective element. Okay, so this is the first step. Once we are done with this, then we can simply use this particular loop to get the answer, right? How we can do this? This is again an important concept and another thing. Let's see how we can do this. So in order to do this, first of all, let me write the heading. Matching index with element, right? With positive elements. Fine. So how we can do this? First of all, let me take the example which is 5, 1, 2. Let's say I have 3 and 4, right? So see here, the order that I want is 1, 2, 3, 4, 5, isn't it? So how we can do this? You can see that for each element in this order, array of I is equal to I plus 1, isn't it? So this is something that I need to check. If this is not true, then I will swap the values. Let's see how. I'll start from this position, right? You can see that the element is 5. So element is, let's say this is ith index. So element is array of I, right? And the actual index where it should be present in is going to be 5 minus 1, 4, right? Because I have to convert to zero based indexing. So the index is going to be element minus 1, which is nothing but reducing the value by 1. For example, this one should be present at 0th index, right? This should to be 2 should be present at first index. This 3 should be present at second index, like this. 4, 4, 3, and then 4, 5. The index is 4, right? So that's why I am calculating the index by this. After this, I will check if my array of index is not equal to element, right? You can see that array of index is what? Array of index is 4 and the element is 5. So I need to swap this particular index, this particular element with the index, right? This is ith position, this is index position. So I will swap the element at these two positions. So I'll say swap uh, array of index and then array of I, right? This is what I can do. Once I have swapped these two values, then I will have the 5 element 5 at correct position. So after this I will have 4, 1, 2, 3, 5, right? Now I'm sure that 5 is present at its correct place, right? But I'm still not sure about this 4. So what I can do with this 4? For this element, I can again check for the same element, right? So for this I'm not going to increase the value of I. So I'll do while I is smaller than n, right? And I is initially equal to 0. So when I swap these values, then I don't have to increase the value of I. And when the both values are present at the correct position, then I will increment the value of I. And else I will do here continue, right? And this is going to iteratively give me the correct positioning of element. Let's see how. For this 4, again the element will be 4 and index will be 4 minus 1, which is 3, right? But the element at index 3, right? And 3 should not be there because 4 should be there. So I need to swap both of these. When I swap these two values, then I will have 3, 1, 2, 4, 5, right? Now you can see that I have got 4 and 5 at correct place. What about this 3? Again for this 3, the element is 3. I'm again in the starting of the loop. Element is 3, then index is 2, right? 3 should be present at 2. So I'll swap these two values. This way I will be able to get 2, 1, 3, 4, 5. Now these 3 are at correct place. I'm at this position. So I will again check. You can see that this 2 is not present at correct position. This 2 should be present here. So I'll again swap, then 1, 2, 3, 4, 5. This is correct order. I'm at here this place. So this condition is not going to true, right? Because you can see that 1 is at correct place. So I'll move here. I'll increase the value of I. Then it is again at same place. I'll keep increasing I till I reach the end of the loop, right? And this way I will be able to get the correct positioning of the element. Now let me erase everything and I'll just keep the code here, right? So this is the code that we have. This is the code. You can see here that I have written the code for matching the indices with the positive elements, right? So once you have written this particular code, once you have written this particular code, then you can simply write this code in order to get the answer, right? And the complexity is going to be O of n for this, and similarly O of n for this as well, right? The complexity is O of n here. This is about n complexity. Space complexity is O of 1, right? Because we are not using any extra space. Instead we are modifying the same array, right? So now let me show you the code. Let me show you the code now. So you can see that I have written a Java code on the left hand side and C++ and Python code on the right hand side, right? So you can see that I'm starting from like this particular step. In this step, I'm matching the every value with the index, right? And after this, I'm simply checking whether the value is present at correct place. And again, the same thing, guys. The answer is going to lie in the interval from 1 to n plus 1, right? This is very important thing to observe. And this is about the C++ code, very similar to the Java code, right? And this is Python code. This is again the concept is similar and only is the change of syntax. So this is all about this video. If you guys like the explanation, then you can hit the like button. Thank you.